Good morning and welcome to Reinvent Your Supply Chain. So for this session, we have brought to you content from Korea, from France, from Germany, and landed all of that on time and in full in Las Vegas. So if that isn't a supply chain achievement in itself already, I don't know. I'm Florian, I'm heading supply chain transportation and logistics across EMEA here at AWS, and I'll be your host for this session. So reinventing their supply chains has become one of the most important topics for many of our customers across the last 3 years. And it's no surprise that the disruptions that we've seen on a global scale have really elevated this topic from the engine room of many companies to the boardrooms. So AWS has always had a very strong history and relationship to supply chain management and reinventing supply chains, starting obviously with powering Amazon.com's supply chain. A supply chain that is highly automated and that is connecting end-to-end, a supply chain that's geared at delivering more than 400 million SKUs to customers on a really speedy scale. So that is a supply chain that is automated, that is connecting forecasting, capacity planning, buying, placement across an extensive network of fulfillment centers, and then obviously triggering an automated, geared for speed fulfillment. That is actually when the clock starts ticking and it gets interesting for the customer. By the way, I highly recommend, also there's a session this afternoon on Amazon supply chain. This is diving deeper and giving a bit more insights behind the curtain on how Amazon is operating its supply chains. So many of those capabilities are also what customers are looking for. And if we look beyond and understand and listen to our customers, what are the core themes that they are really looking for? One is real-time visibility in a true end-to-end fashion. So connecting the dots, understanding from inbound to fulfillment, where's my product, and really bringing this together, also giving visibility to their customers. The second one, driving insights and prescriptive guidance from an abundance of data that's usually there, and transitioning beyond that kind of being stuck with an abundance of data and only just very limited insights. The third one, connecting external sources. Supply chain is a collaboration game, so it's really important for our customers to connect not only just what's within their four boundaries and their four walls, but connect ERP system, connect suppliers, carriers, partners beyond that. So this is becoming more and more important as supply chains really also get more and more global. The fourth one is moving ahead of the curve. So moving into predictive analytics and not only just descriptive and reactive, right? Getting into the decision loops and influencing decisions before a customer actually realizes that there has been a miss in their supply chain. Finally, accounting for a need for resilience in supply chain operations. And that's connecting obviously in crisis situations, but then also post-crisis situations, understanding the exposure of inventory and capacity risks in their supply chains, and then all the while embracing that customers live in a brownfield world, and there's basically a system of record, there are ERP systems that customers have already. So how can they basically move into that kind of space now beyond? So I actually need a bit of your help now. I'm going to ask you a question, and I want you to show with your fingers. So 1 meaning very low, 10, I'm actually running out of hands here, but 10 fingers fully in agreement. How much can you relate to those challenges? How much does that apply for your company? Show of fingers. All right. I see a lot of tens around here. Is there someone raising their foot as well? So I think, okay. Good thing is you're in the right session, and this is what we're going to talk about today. And especially also the exciting part is AWS is providing our customers with the tools, solutions, and services to tackling those challenges. So customers are leveraging AWS services to ingest and connect data from a breadth of existing systems already. That's internal ERP and IT systems, but that's more and more also external data when it comes to weather, social media sentiments, etc. And many of you have probably seen the announcements of the new AWS supply chain service. This is something we're investing in. This is something we're leaning in for as well. And then making it even easier for our customers to connect existing data sources and build that supply chain data lake to then drive to analytics and beyond AI and ML capabilities. And all of that is really driven by customer business use cases, right? So we're not building from the solution, but we're working backwards from a specific challenge to solve on the business side of our customers. But let me make this actually a bit more specific now, and I'm extremely excited to welcome today to this session two of our customer teams speaking about the use cases that they have actually realized. And the first team from Airbus, let me welcome Tony Delaney and Christian Klein.
Thank you, Florian. So, I'm Tony Delaunay. Hello. Digital applications leader in Airbus for the industrial domain. So, do you know Airbus? Airbus is pioneering a sustainable aerospace for a safe and united world. I'm part of the commercial aircraft division, who've sold more than 21,000 aircraft and deliver 14,000 of them to more than 400 customers around the world. With our solutions, we wanted to tackle these main challenges. And the first one, in Airbus, we work in a high complex industrial environment. Airbus is implemented in a lot of countries, on several continents. Airbus, it's also several aircraft programs. You may know the A320, A350, and a multitude of flows, internal, suppliers, and partners. You can see on the map some examples of what we call oversized transports, which means the transport of huge aircraft sections between the different Airbus sites. Transport which can be done by sea, by air, by road, and even by river. The second challenge was linked to the multitude of use cases, of tracking use cases coming from many organizations in Airbus, from the manufacturing and from logistics departments. But the goals are common. The goals are common. And the first one, and the most important for me, we need to deliver on time to meet our customers' high expectations. The second one is linked to the wish to eliminate, or at least decrease drastically, the number of tasks without added values. Get asset status. Where is this asset? And I use it. It's related to calls or search tasks. And finally, having a shared internal and partners visibility with centralized and historized information, reachable at any moment, to be able to analyze the data and optimize our asset using, optimize the flows. This can be about aircraft constituent assemblies, meaning aircraft sections. It can be frames, tools, transport means, and a lot of others. To take up these challenges, we set several objectives. And the first one, we needed to stop local initiatives, meaning stop the development, stop the maintenance of several applications, the same goal. The key message here is think global. The second objective was to be agnostic of the technology, meaning have no preference for one given technology, but be free and be open to use the most appropriate depending on the use case. Thirdly, we wanted a modular and scalable application to be able to cover many tracking use cases. And for example, we faced an increase of 250% of the number of assets tracked in our solution in 2 years. This is huge. And it was key for the success of the tool to absorb this height increase. And finally, one application with control costs. We therefore start from the use case, and depending on the constraints, we select a technology and we integrate it. The result is Way for where are you? Our Airbus corporate track solution to track and trace assets inside Airbus and across the Airbus supply chain. Let's place now to a demo of one use case covered by the solution. The demo is related to the monitoring of aircraft sections transported between several sites. So here you can see the map of Way, on which you can see what will be the journey of the section transported by truck and by boat from one site to another one in France. This is the physical loading of the section on the truck in the departure area. And by using a dedicated mobile application connected in real time to the backend of Way, and thanks to the scanning of the tracking device, we log this operation in the operational planning of Way, which allows us to retrieve it after in the application. And this lets also to materialize the transfer of responsibility between the different service providers. The truck now arrives at the port, and as for the loading operation, we log and we record the unloaded operation and the loaded operation of the section on the boat. Now the boat is loaded and can go. And thanks to geofencing, we generate automatically a departure operation into the planning. And the same for the arrival. During all the journey of the section, it can be geolocated in real time in Way. Here loaded on the boat, moving between the two sites. And you can see the section appearing in the list of the loaded elements of the boat. And more generally, you can track any sections to which you have access in Way in real time. With here an example of section loaded on a truck moving between two sites. And finally, you can monitor the operational planning execution of every transport means to which you have access in the application.
Thank you, Tony. I'm Christian Klein, and I'm the product owner of the Squid IoT platform at Airbus. So now I'm going to walk you through the 4 different steps of the architecture that we have built for this project. Step 1, we perform data ingestion. Airbus has a dedicated team operating the Squid IoT platform, consisting of many components, such as AWS IoT Greengrass and IoT Core. We ingest data from IoT sensors associated with logistics and manufacturing assets. The second step is the preparation of the data. First, with geofencing, which makes it possible to link positions with zones, such as Airbus hangars or production lines. Then, with the contextualization step, using the forecast planning data that is retrieved using AWS Lambda functions. The data is then stored on different formats, S3 for the website and DynamoDB for the contextualized data. DynamoDB was chosen for its ability to support multiple and scalable reads and writes at a contained cost. The fourth part of the architecture is about publication. The data is made available using a web application distributed using CloudFront for the static content. Amazon API Gateway serves a collection of Lambda functions that exchange with our DynamoDB database. Except for the geofencing system, our solution is completely serverless, with AWS managing the server infrastructure and providing its support for us. Across the Airbus organization, the data is also made available to other enterprise systems, such as Airbus Data Lake, to promote maximum reuse. In order to build our end-to-end supply chain solution, the challenges we addressed were as follows. First, building a secure, robust, effective, efficient, and performant architecture, which is respecting the guidelines of the well-architected framework. Second, scaling from an application serving one use case with several sensors to multiple clients and almost 10,000 of sensors. Building internal and external AWS skills by, for example, setting up cloud champions within the dev teams. And manage a proper device lifecycle for more than 17,000 sensors with an increased fleet of IoT sensors. This is a complex part that had to be done in collaboration with many teams at Airbus. The key success factors were the creation of a global platform in charge of cybersecurity, networking, identity management, the creation of a global enterprise platform in charge of IoT, performing the data routing and processing, as well as managing the lifecycle and the monitoring of the sensors. And finally, at the application level, the organization of the team in DevOps mode to make sure that those who develop can operate as well. As for the lesson learned, we would like to provide you the following advices. So first, get support from AWS and from your partners. You should really rely on experts. Then, take time to stabilize the foundation and to refine the target architecture. This is not lost time. And finally, be agile and use infrastructure as a code to improve at each iteration with some tools such as CDK. Today, Way and the Squid IoT platform have enabled the optimization of the end-to-end supply chain at Airbus. It supported a growth for 7,000 to 17,000 tracked items in 2 years. It also enabled the creation of performance indicator for the supply chain. The next step is to offer more than geolocation. In the future, new use cases, such as monitoring the state of the containers, whether they're full or empty, or monitoring the freezers, will emerge. With the use of AWS IoT events, the idea is to set up an alert system based on temperature thresholds that will trigger the intervention of technicians to avoid scrapping of aircraft parts, which is really critical for our activity. Tomorrow, we will also implement further predictive algorithm to optimize the supply chain. And we also make sure that we are 100% serverless. Thank you. Back to you, Flora.
Thank you so much. Thank you so much, Tony and Christian, for walking us through that example. And obviously, this is one side of the spectrum, moving aircraft parts. Now let's shift gears a tiny bit. And I'm very, very excited to now welcome on stage Subin Kim and Juman Kim from Samsung Electronics. And they're going to talk about a tiny bit of a different product. So welcome.
Thanks, Florian. Good morning, everybody. I'm Subin Kim from Samsung Electronics. Today, I'm going to talk about how we transform the demand forecasting process for Samsung Electronics with AI, machine learning, and big data, and AWS with my colleague, Juman. So before I begin my presentation, I want to ask a question. Is there anybody who ever used Samsung Electronics products? Thank you, guys. Please continue to do so. So, in case you don't know what we do, brief introduction. We are the largest electronics manufacturer in the world. In every year, we build, ship, and sell more than 500 million mobile phones, wearable devices, TVs, and home appliances to the global market. So to achieve this massive volume of scale, we operate complex global supply chains, starting from 32 production sites, which are placed strategically for optimal buying, manufacturing, and global shipment. And there are 52 sales offices worldwide with logistics and marketing capabilities supporting multiple or single countries. So how Samsung supply chain work? We buy raw material and parts from many vendors and turn them into final product in production sites, factory, and ship large inventory to a distribution channel. And the products flow through the distribution channel and find you guys in you all in retail stores. So to reach as many as consumers as possible, we operate a number of supply chain or distribution channel model. I'm gonna name just 3 major cases. First one, production site or factory ship large size inventory to Samsung's own network of warehouse, and our partners, retail partners or distribution partner, as a customer, they buy wholesale inventory from our warehouse and do their distribution, supply chain, and retail, and these products find you in the retail stores. Or if we don't have our own network in specific region or country, we can ship directly to partners' supply chain, and they do the rest. And number 3, we have our own retail, online and offline, so we are able to deliver product directly to your premises, or you can come to our stores and pick up products directly from our retail channel. So to operate and plan all this supply chain, we have global supply chain management system and process, and the planning goes from purchasing, production, and distribution, and all the way. And the forecast is the crucial input to the system. Forecast, the definition is process of making prediction of the future based on the past and present data. And our forecast tells the system how many units are going to be sold, where and when. So the rest of supply chain is going to be ready by these forecast numbers. And we do 2 kinds of forecasts. There are thousands of demand planners working for sales offices and headquarters, and they do this 2 kind of forecasts. One is sell-in, the other is sell-out. So when we sell inventory, large inventory to a distribution channel, that is called sell-in. So this is wholesale part, and it's about building inventory in the distribution channel. So it's just supply driven. It's somewhere between what we want to sell to the market and what they want to take. So a lot of human intelligence and negotiation going on to make this forecast. On the other hand, the sell-out forecast is about you guys, you all coming to our stores and picking up products from us. So it's market-driven, and many market dynamics and data impacting this forecast, such as economics, competitor activities, promotions, price, and some supply factors. And we get help from artificial intelligence to do it properly. And you might be wondering why we do both, because when the product leave our supply chain and our partners do rest of the supply chain, it's their business, right? But the reason is that we want to have healthy supply chain all the way from our inside Samsung network and the partner supply chain network. So let's say there is a very optimistic distribution partner of us, and they want to take a large inventory, and the market is slowing down, and they want to do it anyway. Then we have to persuade the distributor to do otherwise. That way, the distributor's supply chain gets healthy, and our supply chain gets healthy. So these days, the sellout forecast is our priority, and sell-in forecast is made afterwards. So the journey to sellout forecasting was not easy. We took time to build the process and still doing it. So this slide is about 15 years of history summarized in just one page. For a very long time, after inventories leave our supply chain, we didn't have any systematic way of tracking it in our partner supply chain. Even if they are sitting in their warehouse or some retail stores, how they are selling in some part of the region, we didn't know until they tell us. So we started by building data pipelines from the partners. So POS data and channel inventory data we are receiving on a daily or weekly basis. And from activation data from smart or connected devices such as smartphone or smart TVs, we are now able to get real-time sales information as soon as it happens. So after we build some data, historical data and visibility, thousands of our demand planners started sellout forecasting. And at the beginning, without proper training and time and expertise, the accuracy was not very good. So that's when we came up with our first sellout forecasting service with a statistical model. And it gave them a reference point to start with. So they can take a look at our number, and they can add their own insight there, plus or minus, and went from there. So the accuracy problem was solved somehow with this statistical model. And after seeing the success, many sales offices was requesting features to our statistical model. They want to have a customization for additional variables and special events going on that particular market. But our old pipeline and modeling and resources was not efficient for that kind of customization. So 52 sales offices, all the product categories and all the different dynamics going on the market, not good. So in 2018, we developed machine learning-based forecasting model based on 3 algorithms. And we build customized model for every market and product categories and try to input all the variables there. And the accuracy improvement was huge, and we were very happy about it. But within a year, we reached an accuracy saturation point. Accuracy was no longer getting improved, and people want more. And our model was not performing well in particular market segments, such as small volume SKUs and sparse demand patterns. So that's when we want to explore more. So there are deep learning algorithms and time series algorithms and ensemble and stacking, many good approach to do forecasting in a sophisticated way. But our old infrastructure became the bottleneck then. So we were running 11 nodes Spark cluster on premise with the 2 GPU servers. And at the beginning, it was pretty good. But when we want to try all the different combination of modeling, variables, hyperparameter optimization, and we want to try that in parallel way, infrastructure gets on our way. And all the data pipelines getting longer and bigger. And we just had 4 hours to forecast and validate and send our forecast to the SCM system. If the pipeline gets failed, it was a big problem to us. So that's when we decide to move the cloud to get performance, scalability, and reliability, of course, the cost. So my colleague, Juman, will take you through the rest of our journey. Thank you.
Thank you, Subin. So I'm Juman Kim, one of the colleague of Subin and data scientist at Samsung Electronics. So here is the brief overview of the key functions of our demand forecasting system to serve complex machine learning models. It roughly shows which AWS services we are using at a glance. Our system simply ingests market data and internal data, pre-processes for analytics and modeling, and serves forecasts to our demand planners. As Subin mentioned before, when we design our system architecture, we keep in mind to achieve better performance, lower cost, more reliability, and more scalability. And thanks to solution architect team and ProServe team of AWS, and of course with hard work of our in-house engineers, we could make a concrete design and migrate smoothly from on-premise to the cloud in 6 months. From now, let me introduce 3 anecdotes of how we experience benefits from utilizing AWS services, which is EC2, EMR, and SageMaker. It contains 3 most significant jobs of our forecasting service. That is ML model development, scalable data processing, and large-scale training. The first case is when our team of data scientists working on developing machine learning and deep learning models at the same time. When multiple projects and training jobs require more computation resources than what is given to us, some jobs of lower priorities had to be in a queue to be processed. Let's say Subin is using every computation resources, then I have to work late at night until his job is finished. With on-premise environments, we had a limited capacity, but also limited options of computation hardware. Also, in case we decide to scale out on-premise computation resources, we should pay additional fixed costs, even if it is not fully utilized after the project is done. But by using AWS EC2, we enjoyed unlimited capacity of computation resources at will. We only had to pay as we use while the development project was ongoing. After the product is done, we have no worries on additional costs due to unused idle resources. Also, with wide selections of hardware options, we could choose the most efficient type of EC2s for each respective jobs in terms of cost and performance. The second case is when our data engineers had to expand the data pipeline in a very short period of time, from few countries to and products to many countries and more products. The forecasting service coverage is expanded from 3 product categories and up to 10 categories, and 5 countries to 74, which results in more data, more tasks, more models, and more batches. When we fail to process data and provide to our demand planners, we face great disaster because not only our system has failed, but also their system will fail. With AWS EMR, it was easy to scale out just by a few clicks. And we also could manage our computation resources cost efficiently by auto-scaling and scheduling. In general, data flow jobs are not equally processed every hour, so sometimes there is a lot of data to be processed, and sometimes there's little. Thus, we should aim to utilize cost efficiently our resources. With options of on-demand and spot instances and transient clusters of EMR, we could manage cost efficiency while serving much greater data flows. The last case is when ML engineers had to train and update numbers of our machine learning and deep learning models in regular basis. We have thousands of models in productions which had to be retrained regularly. Before using SageMaker, we had to connect individual EC2s to perform training jobs and store the output models that involved repetitive manual works and manual retraining when failed. But with SageMaker, we could easily monitor training jobs and retrain when failed. We could automate the retraining process, which lessens human works and human involvements and human errors. That consequences less training time and cost overall. Moreover, it was hard to monitor each preceding training jobs in depth beforehand. But with SageMaker and CloudWatch, it becomes super easy to manage and search of logs and troubleshoot when jobs failed. As a result of migration project from on-premise to cloud, now we have zero worries about the infrastructure. Our data scientists and engineers could test a variety of complex machine learning and deep learning models in a very short period of time. And with these complex models, we could achieve improvements on the forecast accuracy. So based on the improved results, we could persuade our demand planners to automate their demand forecasting operation. And overall, our system contributes to lower stockout and revenue growth. Our journey of demand forecasting is not on the last page. We are going towards collaboration between human and AI as the next chapter. Still, the role of human is crucial in that they have understanding on the market, which some of it is still usable, but it's not extracted as a usable data, but could be critical to demand forecasting. That's why our next challenge is to serve more explainable forecasts. With the explainability of our complex models, our demand planners can analyze how the forecast is created, can provide human input as an additional parameter that AI couldn't handle, and also they can simulate the forecast values, and they can finalize the forecast. To meet these requirements, we are continually modernizing our system with cutting-edge MLOps and DataOps technology. So this is so far is our story. We greatly welcome any discussions and collaborations. Please feel free to reach out to me or Subin for that. And thank you for listening to our talk.
Brilliant. Thank you so much, Team Samsung and Subin and Juman for walking us through this. So I think it's been fairly exciting to see how customers in very distinct use cases basically use AWS services in digitizing and revolutionizing their supply chains. Thank you so much for the discussion. We're going to be around at the back of the room for a bit of deeper dive discussions and follow-ups on that as well. Thank you so much for participating in this session, and please do make sure to complete the session survey afterwards. And thanks again to Team Airbus and Team Samsung.
Thank you.